Hello, everyone. As I was saying, I'm Sai Chander. I'm currently working as a tech lead with SixSense. It's a startup. So I have an overall experience of around 7 to 8 years, mostly focused towards backend development. But today, my topic is mostly related to securing the web applications. You could say it's a little bit of DevOps. Not sure how many of you actually have, you yourselves have generated the SSL certificates for your websites or applications. Maybe just give a raise of your hands if you have done it previously yourselves. Wow, that's quite a lot of people. That's good to know. So yeah, at least I'll be, since the topic I want to focus is mostly related to the Acme protocol. I would probably just skim through the basics of SSL a little faster, since most of you also seem to be aware. But yeah, feel free to ask questions. You can stop me at any time if you want, or you can even ask at the end of the presentation as well, right? Cool. So yeah, let's get started. I think, yeah, I think it's visible. Cool. Yep. So the agenda, why is it? Okay, cool. Yep. So this is the overall agenda for today. It will basically start with the explanation of the SSL and HTTPS explanation, maybe you can say, right? And then, hello, okay, yeah, and then we'll move on to the generation of the SSL certificate, like what are the different steps that it involves, and then we'll move on to what is Acme protocol, how it works, right? And yeah, I mean, what are the benefits of it? And then I'll probably try to do a quick short demo to generate a certificate, because it hardly takes 1 minute to do it right now, if you have the right setup. So yeah, I'll just quickly do that. Yeah, that's the agenda for today. Cool. Okay. So right now, coming to SSL, right? So what is SSL? So it's basically an encryption mechanism for the data that gets transferred on your, internet, or any big, if you want to connect any two servers over external networks, or even in your internal network, if you want to have an encryption enabled, right? So SSL is generally the go-to standard. So it's the encryption mechanism that is helping us keep our data secure while we are doing any kind of interactions over the web these days, right? So yeah, I mean, that's the SSL, and you must have used HTTPS on your everyday basis. HTTPS is nothing but HTTP protocol working together with SSL to make things secure. So HTTPS is simply that, right? So SSL, as I said, it's basically an encryption protocol, right? So you must have heard SSL certificates quite a lot of times, right? So what are these SSL certificates? So you can consider SSL certificates as, your passports, right? So for example, if you go to airport and trying to go to other countries, or maybe if you go to any other place and where you are required to show your ID card, you may show your passport, right? So your passport is basically issued by government of India, or basically any other country, right? So this passport is acts as your identity, right? Similarly, SSL certificates acts as identity for the websites that you are trying to access. If the site is provided with a trusted SSL certificate, we can assume that, hey, we are communicating with the right source itself, right? So in the case of physical world, where I was giving an example of our personal passports, right? So basically, these are generated or provided by governments across the world. For example, for me, it's government of India. For someone, it could be a government of different countries, right? So while putting the analogy here, the governments become certificate authorities in terms of SSL certificates. So certificate authorities are those authorities, and certificate authority can be anyone, frankly. Even I can become a certificate authority. But yeah, there are a few, actually quite a lot of certificate authorities which are quite popular and trusted globally, right? So yeah, I mean, so these certificate authorities actually, you can say, not generate but sign your SSL certificate, making them, if I present my SSL certificate to someone, and if it's signed by a trusted certificate authority, then you can know that, hey, this is valid certificate. So yeah, you can trust on that identity. So that's how the SSL certificates work overall, right? So yeah, I mean, I think I've covered. So why is it crucial? I think you all know why SSL is required or the secure transactions are required. So I'm gonna skip that for now, right? Cool. I think it should be visible in the TV if it's not very clear from here. So this, I will not go into depth about this because my talk mostly focuses on the generation of the SSL part. In this slide, what I'm going to explain quickly is about the different sequence of steps as to how the SSL works when you are using it in your browsers or probably at any other places, right? So generally this provides a sequence diagram. By the way, if you happen to generate a lot of sequence diagrams and if you find, the tools like various tools very, tough to draw the arrows and all, there is a language made for generating these kind of diagrams named Mermaid. So you can use that also. It's quite easy. I know it's off topic, but yeah, I just thought I could tell all of you that. Cool. Now going back to the topic at hand. So yeah, I was saying, so you can say there is a client and a server, right? So these two want to communicate with each other, and server could be, let's say, my website, saichander.com, or it could be facebook.com or any other website, right? So now any client could be anyone, like it could be my laptop or anyone's mobile or anything, right? So basically whenever there's a communication happening between these two, so these are the essential steps that occur in order to make your whole communication secure. So first the client sends a request to the server, then the server responds with an SSL certificate that is of that server. Excuse me. Yeah. So the server, let's say, is facebook.com, right? So facebook.com responds to the client with, hey, this is my SSL certificate. You can check its authenticity by checking if it's signed by the certificate authority you trust or not, right? So the client basically just does that. So I think I'll just use the cursor to point out to different steps, making it easier. Where is the cursor? Okay, it's here. Yeah, so the first step is connection request gets initialized, and then the server sends back an SSL certificate, and the client basically validates that SSL certificate if it's actually like the client can trust that SSL certificate or not. So what happens in our laptops or any other devices generally is they come pre-installed with some of the globally trusted certificate authority public keys, you can say, using which we can validate if a SSL certificate is valid or not, right? Or basically can be trusted or not, right? So once the client validates that, so what client does is it basically generates a random string which is called pre-master secret and encrypts it using the public key that is from the SSL certificate sent by the server and sends it to the server. Then server has the private key. Only the server has the private key, no one else, which decrypts to get this particular pre-master secret, right? So now client and server share a specific secret using which they can generate symmetric encryption keys in order to transfer any data using symmetric encryption moving forward, right? So why symmetric encryption? Like we already have the asymmetric keys in place. Why not just use them, right? So symmetric encryption is generally considered to be quite fast when you compare it to asymmetric encryption and decryption. Yeah, so that's the reason most of the protocol is on the SSL side follow the symmetric encryption by sharing the secret key, right? So yeah, I mean, if you have any questions related to this, we can take them at the end. The reason is I have more things to go about. Yeah, so moving forward, what happened? Okay, cool. So now coming to the topic at hand. So what we are going to discuss here is the in detail steps of what are the different steps that are involved when generating an SSL certificate, right? So here in this sequence diagram, we can see that there are, around 4 actors to say, right? So the first is server admin, let's call it me, and the server, maybe my laptop, right? And then there is a certificate authority, and then there is my DNS server, you can say, or a file. These are the steps which I will talk about one by one in order to explain, how do you get or generate a new SSL certificate which you can use. Okay, cool. So the first step is the server admin or me. I will basically try to generate a cryptographic key pair, right? So it's basically a public and private key, right, which I generate on my server. And using that particular public and private key, I try to create a CSR file, which basically will include the contents such as my public key, and my domain name for which I want to generate the SSL certificate for, right? It could be saichander.com or any other website that you already own, right? And of course, you can do it for other websites, domains which you do not own as well. But yeah, it depends again on if it's a private certificate authority you have or not. But yeah, overall, that's the gist is that you generate the CSRs for the domains you own in general, and then you basically submit this CSR to the certificate authority. So the certificate authority could be, Let's Encrypt or a bunch of other providers, or it could be you, like myself as well, if I want it to be that way. But no one trusts me to generate the certificates for everyone across the world, so it will become like a private SSL certificate if I sign it, right? So yeah, once the CSR is submitted, I think I should be using the pointer. Yep. So we are at this step. So where we have submitted the CSR to the certificate authority, right? After which certificate authority takes the CSR and tells or gives a challenge to me saying you need to prove that this domain or basically the certificate you are trying to generate actually belongs to you, right? Because certificate authority needs to know that I own saichander.com and not someone else, right? So what we need to do is, so the authority will give a challenge, for example, saying post something at, acmechallenge.saichander.com, which should return me a random string which is generated by the certificate authority. It's just an example. There are a bunch of different ways to do this. But yeah, so that's the challenge that a certificate authority can give a server admin to do, right? So based on this challenge, the server admin or me, I will go and configure my own DNS server in such a way that it meets the challenge. Since I own the domain, I have this flexibility to configure a subdomain or maybe some other rule on my domain which I own to return this specific string that the certificate authority wants to see. So once I am able to configure this DNS challenge, I will inform the certificate authority, right, saying that, hey, my work here is done, like I have accepted your challenge, now you can go ahead and validate if you think the configuration I have done is fruitful or not. So once I inform that particular thing to the certificate authority, it performs the validation by calling that particular URL. It could be acmechallenge.saichander.com or something else, right? And tries to see if it returns the string that actually it generated when giving the challenge to me. If it matches, then the certificate authority considers it as the validation complete, or basically I am able to prove that I own the domain saichander.com, right, to the certificate authority. After verifying that, certificate authority issues an SSL certificate to me, and basically I install this SSL certificate in my servers. And that's how you get the SSL certificate and you install it in your servers, right? So that's the whole process. So previously what used to happen, the steps are same previously as well, most of the time, for the most part, right? But a lot of these steps used to be manual. In some companies, every single step. For example, if you have to submit your CSR to the certificate authority, right? Previously, it used to go by emails or some other mechanisms. relatively secure mechanisms, but it used to take 1 week or 2 weeks or even more. Sorry, just a moment. Even more to generate a single SSL certificate. Right now, in the current world, it could happen within a few seconds, right? So that is all thanks to the ACME protocol. I mean, there are a few other protocols as well, which probably came a little before, but yeah, overall, ACME protocol is super widely used and super popular right now, right? Cool. So I'll just give a quick introduction about ACME protocol. It's basically Automated Certificate Management Environment, the abbreviation. It's designed by Internet Security Research Group. So yeah, it's a very big group. So they have created this protocol for their own Let's Encrypt specific way that is mentioned in the ACME protocol documentation. You can find that in the last point link, which I have mentioned here, right? So these are some of the resources and the APIs provided by the ACME protocol. It's not exhaustive. I've just given it to have some examples. So some of the APIs are like, hey, I want to get the challenge. I want to finalize the order, meaning that I have performed my DNS queries. Now I want to just, yeah, finalize the order. Basically, you can validate it now, right? Cool. So this is again the ACME protocol. So basically the older thing, I have trimmed down a few parts just to make it relevant for this part, right? So it has two things, ACME client and ACME server. You can consider ACME client as the server or server admin in the initial diagram, and ACME server is basically the server which hosts these ACME protocol APIs, which I was talking about, and the certificate authority and ACME server generally reside together, but they can be separate as well. So the steps are again the same, but it's just that now using this ACME protocol APIs, you can automate every step until you get the SSL certificate. Like you request a certificate and it instantly provides you a challenge to validate the domain, and you can write you can have your ACME client to basically write your code to change the DNS servers automatically, right? Depending on what your DNS server is, if it's Nginx, most of the I'll come to give an example of few ACME clients that are already open sourced and very easily available and very easy to use. They have a lot of plugins to, for Nginx, common things like Apache or Route 53 or Google Cloud DNS, right? So all of these things, you can easily configure them in your ACME client to configure these DNS servers based on the challenge that is given by the ACME server, right? So yeah, again, so ACME client basically responds to the challenge and ACME server is now able to validate. So the steps are still the same, nothing has changed except that everything can be automated just thanks to the ACME protocol that everyone is following nowadays using their API, right? Cool. So benefits, I've been talking about it. It's basically mostly related to the automation and of course the security. Now that generating the SSL certificate is so quick and so easy that everyone easily can adopt to the best security standards for transferring the data over the web, right? And yeah, the cost is very cheap nowadays. Like a lot of certificate authorities even provide free certificates as well. Like Let's Encrypt is one of them. So yeah, coming to the Let's Encrypt. Let's Encrypt is a certificate authority which is trusted globally. They offer free SSL certificates, right? And they have the API implementing ACME. So this is the first certificate authority which has come up, basically implemented the ACME protocol. Right. So there are some popular ACME clients here, certbot, acme.sh. These are open source libraries which you can use. Certbot and acme.sh are really popular and really easy to use. So if anyone wants, I would recommend them both. They are really easy to use, especially if you have any traditional ways like you use Nginx server or some of the popular cloud providers DNS like Route 53 of Amazon or Google Cloud DNS. Yeah, you can go ahead, right? So depending on the time we have, I might opt for a demo, or if we don't, then it's fine. Okay, I'll just quickly take like maybe 1 minute because I just need to run these two commands is all. So let's see how it goes. You can see on this particular domain, sai.sixsense.ai. Sixsense.ai is my company and they won't mind if I use a single subdomain temporarily for this demo. So yeah, I have hosted a temporary web server of Nginx here, right? Which is, yeah, I mean, as you can see, it's insecure. It's not working with HTTPS right now. If I try to get it working with HTTPS, you will see an error because it's not configured right now, right? So yeah, so this is what I have, and what I have here is basically this is the server on which that web page is coming from, right? So I'll just run a couple of commands on this server. Since it's running with Nginx, you'll see how fast it is. I'll just copy paste the two commands which I was showing earlier. Okay, let me just turn off the projector for an instant so that I can copy. To install the certbot acme client, this is the first client I was talking about earlier, right? I just need to run this command to install, and 1 second. Yep, it should be installed in a second. Is it done? Yep, it's done. So I will run my second command. What? Something else got copied. Let me copy again. I'm providing my domain name and nothing else. And it asks for an email generally. I'll just put random thing. As you can see, it just asked for an email. I'm just writing some random email temporarily, but yeah, I would advise you to give your own email where you can do, if basically it creates an account for you to manage the certificate. Yep, we just need to accept their terms and conditions, or yeah, like terms of service. And yeah, I don't want to participate in any service right now. So yeah, as you can see, I just need to do this, and it's automatically goes and edits the Nginx configuration files as well. I don't need to do anything. So it says, hey, congratulations, your certificate is already created and it's saved at this particular position. And since I have mentioned in my command earlier to use the Nginx plugin, so it automatically overwrites my Nginx config files as well. Now let's go back to the original one and refresh. So you can see that automatically my HTTP thing is redirected into an HTTPS site, and now you can see that the browser trusts the certificate that it's generated is secure as well, right? It's as simple as that. Of course, it's very simple for the Nginx, but yeah, there could be other DNS providers which may not have those simple plugins, and you may have to write your custom extensions. But yeah, Surfbot and acme.sh have really good extensive framework so that you can write your own things. I think I will stop now in a minute probably. Sorry about that. So, yep, I think that's more or less it, right? Okay, just one announcement. If you any of you are looking for a senior front-end role, we are hiring at SixSense, so feel free to reach me out at LinkedIn. Yeah, that's it. Thank you. Sorry for taking a longer time.
Thank you, Sai Chander. Thanks a lot. Thanks for that very deep dive into the Acme protocol. Does anybody have questions? Thank you.
Thank you, everyone.